Okay, question 5, work, energy, and power. Thanks for tuning in. Thanks for watching. Check out the description box. Kunama links for other questions and for this question paper. There's also a link to another channel for AMA lessons. I would appreciate it now we are subscriber to that channel as well. So, yeah. Asibheke laba siphetheleni. What a roller coaster cart of mass 2 kg is released from rest, initial velocity 0, at point A, 30 meters above the ground. The cart moves along a frictionless surface A, B, C as shown below. So work, energy and power, it's not a topic ephelela lana ka grade 10. Ka grade 12 isasekhona. But ka grade 12 seba introduce namanye ama theorems nje. It's E1, maybe 2. Yeah, 2. Yeah, 2. But there are theorems uzobuwafunda ka grade 12. So I apply ku work, energy and power. But basically whatever uyenzayo la naka grade 12 usazoyithola. Alright, roller coaster ride, you move from A to B to C. Oh, le roller coaster ride nangayigibela le mosisiyo wala. Siyo after C siya wala. They should have extended this thing maybe by 3D nyana or something to be more convincing. But anyway, it's just a rough sketch. Lagu 5.1, but it's define the term gravitational potential energy. What is potential energy? Nangabe umile on the ground, your potential energy is 0. Nangabe ugibela phezu kwendlu khayigini, your potential energy has increased, right? In terms of ilugans, in terms of physics yethu la, right? Okay. Lana potential energy ku 5.1, we can define it as energy an object has as a result of its position above the surface of the earth. Basically it's what I was describing la ukuthi now ku ground una zero potential energy, now uyaphezulu na potential energy yakhe ya increase. Sometimes unokuzwa mhlambe if ever you are good in something, or let's say mhlambe uzama mhlambe ukudlala ipiano or uzama I don't know, uzama mhlambe ukubhaka amakhekhe or something, yabona, bese uyayenza uzwa abantu mhlambe bathi wow amnandi amakhekhe wakho, then ubezwe bathi une potential, you can go places, you can go somewhere ngalento, you can even open a business, you got potential energy, it's that latent energy onayo, right? Even ilogans, like everyone has energy, has potential energy in terms of physics, energy in terms of physics. Umzimba wakho nabangawuthatha bawushise uzowenzani, release ini energy, that's a form of potential energy, right? But lagu physics it defines as the energy an object has as a result of its position above the surface of the earth. But ungakhohlwa, you as a mass une energy now, une potential energy now. 5.2, you are capable of doing anything, you got potential, man. Yeah, prove the calculations that the mechanical energy of the cart at point A is 588 joules. So mechanical energy, let's say EM to represent the mechanical energy is equal to the sum of kinetic energy and the potential energy. So it's 1 over 2 mv squared plus mgh. It's half. What's the mass? 2. Right. And then lana kuba 0 squared. Ngoba at A it's at rest, so the velocity is 0, right? Plus mass 2, gravitational acceleration 9.8, height 30. Alright, asibone ke calculation lethu lithini la. So it's 1 over 2 times 2 times 2 or bracket 2 times 0 squared plus 2 times 9,8 times 30. Answer is 588. Now answer it again. So bar right now, but the mechanical energy at A is 588. State the law of conservation of mechanical energy in words. 5.3 CT, the total mechanical energy, the total mechanical energy is conserved in an isolated system. In an isolated system, the total mechanical energy is conserved in an isolated system. This is a question on I told na grade 12. I've seen a question where to state the law of conservation of mechanical energy. Yes, so ngasho ngithi maybe about 40% of syllabus ka grade 10 ungayithola on a question paper ye physics ka grade 12. Yes, so 40% of your syllabus, it's very crucial in your grade 12. Now 5.4 but is calculated the velocity of the cart when it is at point B. When it is at point B. Space is enough now. Let's see. Alright, it's for calculate the velocity. So sevens are the conservation of mechanical energy to calculate a velocity at point B. Sitini EM at A is equal to EM at B. EM at A, the mechanical energy at A is 588. The mechanical energy at B, we have to calculate this. MV B squared plus MG H at B equal to, we substitute again, mass to velocity unknown plus mg, m it's 2 9,8, this time the height 10 at B, right? 588. We calculate again, much 1 over 2 times 2, it's 1. So lana, there's no need to put in calculator. So it's 2 times 9,8 times 10. This is equal to 196. Lana, it's half times 2, it's 1, so it's VP squared plus 196. 196. Oh yeah, 588. Therefore, sizala, we transpose law 196 due to 588 minus 196 equal to VP squared. We calculate 588 minus answer, it's 392. 392 equal to VP squared. Then in tata the square root on both sides. So the square root of the answer is equal to 19,8 into decimal place. 19,80. It's our velocity lagupi, no squared, in meters per second. Now so 19,80 meters per second. The answer is actually. Alright, last question, 5.5. How will the mechanical energy of the cart at point C compare with the mechanical energy of the cart at point B? Write only greater than, less than, or equal to. Give a reason as well. So at C, the mechanical energy is equal to ngiphendula 5,5 now, is equal to B. Yes, is equal to B at C. Why? It's because of this is Okay, asithi maybe singathi mechanical energy is conserved. Agna friction, there's no external force, so mechanical energy is conserved. Mechanical energy is conserved. Alright, this concludes our question 5. Check out the description box for more content on Ibugela. For now, I would like to say asibonane the second half. Ungakhohlwa ukulike, ukushare, ukusubscribe. But this is the only way ungasupporta this channel, guys. Asibonane on the next one. Bye bye.